In this video, I am going to solve this system of linear equations using the elimination/addition method. However, before I solve this system of linear equations, I need to make sure that I have the equations in this format: ax plus by is equal to c. That means the xy terms are in that order in the left and the constant is on the right. The first equation seems to be okay, this one. However, the second one is not. So I need to simplify it and then put it in this format. But what I am going to do here before that is actually in the first equation I am going to get rid of the decimals so that my calculations become easier. And in the second equation I am just going to do similar thing, get rid of the denominator, and then reorganize the terms in such a way so that I have this structure, which is ax plus by is equal to c. Now let's look at it. The first equation has a bunch of decimals, but the highest number of digits after the decimal is 2 here. So on the right hand side you have 2 digits after the decimal, on the left is just 1. So to get rid of the decimals in the first equation, I need to multiply both sides of this equation by 100. If I did that, I am going to get 10x. 0.1 times 100 is 10, by the way, and then multiplied by x, minus 0.3 times 100 is going to be 30. Y is equal to 0.25 times 100 is 25. Now I have all integer coefficients. However, I can simplify it a little bit further. Note that all these numbers are divisible by 5. So this is divisible by 5, this is divisible by 5, this is divisible by 5. In essence, I am dividing the entire equation by 5. So that gives me 2x, because 5 goes into 10 twice. So 2x from the first term, and from the second term 5 goes into 36 times, negative 6y is equal to 5 goes into 25 5 times, which is this. So this becomes my simplified or modified version of this equation. So I'll keep those things on track. Now let's go ahead and talk about the second equation, which is in the form y is equal to mx plus b, this equation. So y is equal to mx plus b. So we have y is equal to negative 2 over 5x plus 1. Now to get rid of the denominator, I just multiply both sides of this equation by 5. Multiply everything by 5. On the left hand side I get 5y, and on the right hand side I get this 5 and this 5 cancel out. That gives me negative 2x, because 2 times x is 2x and the negative, and then 1 times 5 is just 5. Now I can add 2x to both sides. Okay, add 2x to both sides. In that case I will get on the left hand side 2x plus 5y, and on the right hand side negative 2x positive 2x cancel out, and that leaves me with 5. So this is my second equation, which by the way is the simplified version of this. Now I am going to rewrite these two equations and put it together. So this equation becomes this and this equation becomes this. These are my equivalent system of equations. Now I am going to take this system and solve. I could do the usual thing here, multiply get rid of the x and solve for y, because the coefficient of x is 2 here, coefficient of x is 2 here. Multiply the second equation by first one, second equation by negative 1, and then add. However, instead of doing that, what I am going to do, rather, I am going to just subtract the second equation from the first equation. If I did that, look, 2x minus 2x is going to be just 0. Then negative 6y minus 5y is going to be negative 11y is equal to 5 minus 5 is 0. Or I have negative 11y is equal to 0. If I divide both sides by negative 11, I get on the left hand side y, because negative 11 is going to cancel. On the right hand side 0 divided by negative 11 is 0. That's what it is. So y is equal to 0. Let me kind of touch on this thing a little bit closely. 0 divided by negative 11, that's by the way equal to 0. However, if you had negative 11 divided by 0, that's undefined. This one is undefined. Sometimes students get confused which one is which. When you are dividing 0 by a number other than 0, it becomes 0. When you are dividing any number, including 0, by a 0, this becomes undefined. So I just found y is equal to 0. Now that I found y is equal to 0, I can go ahead and find the x equal to x value as well. Instead of going through all the elimination, I'm just going to solve it slightly differently. I could go ahead and eliminate y and solve for x in this system, but I'm not going to do it. Since I already have y and y happens to be a pretty nice number, which is 0, I'm just going to take one of the equations. So the first equation, let's use that one. 2x minus 6y is equal to 5. But my y is 0, so I'm going to just plug in the 0. 2x minus 6 times 0 is equal to 5, or 2x minus 0 is equal to 5, or 2x is equal to 5. Divide both sides by 2, that gives me x is equal to 5 over 2. So I just found the point. So my x comma y is equal to 5 over 2 comma 0. Now what does it mean? It means the following. If you have these two straight lines represented by these two equations, okay, again this is a sketch, this is not exact drawing or graphing. What in essence you are doing, you are finding this point of intersection. So this point is gonna be this, which is 5 over 2 comma 0. The coordinates of this point is 5 over 2 or 2.5 comma 0. Now when you are solving a system of linear equations, you are finding the point of intersection, meaning you are finding the coordinates of the point of intersection. That coordinate is going to satisfy all the equations in the system. In our case, we have only two equations, so this point 5 over 2 comma 0 is going to satisfy the first line, or the first equation is going to satisfy the second equation as well. That's what it means. I hope that this discussion was helpful. Thank you very much.